Welcome to another session of Tech Time. Hope you're all doing well and enjoying warmer weather. And today I want to talk a little bit about some refrigeration practices concerning reversing valves. We all know they're kind of a headache to diagnose and sometimes headache to service. So let's get rock and rolling. If you got any questions, glad to send us a note. You have some other webinars you'd like us to talk about, send us a note as well. And if you got any questions, well, you send them to us in our email list there below. I am Jim Strandlund, one of the tech services specialists at Intertech, and look forward to answering any questions you guys have. There's some phone numbers there for you to use, and my email as well. Hey, we're sponsored by Intertech University and Intertech themselves, Energy Technology. Remember, Intertech is also a solar distributor, and we have some good variety of equipment for you as well. So please and thank you for watching today. Here's some of our members in that you put a face to a name. And as always, we're always here to help and welcome any questions or answer we can help you out with. All of our tech times and all of our videos and all the stuff are stored at Intertech University at the YouTube channel. You're welcome to take a look at them there and review these as you wish. And other webinars and trainings are available there to review. If you click on the playlists, and you'll come up and you'll see there's a whole bunch of different tech times we've been doing to review and go through over and use them as you desire. But today I want to talk a little bit about troubleshooting a reversing valve, and I'm gonna read this to you so it's easier to see. But one thing to remember, there's some different types of failures with reversing valves. It could be the solenoid coil. This thing could be stuck in heating or stuck in cooling, or it could be stuck somewhere in between. Your coil failure is, usually pretty easy to fix. Obviously, you can replace the coil, and on the reversing valve, you'll see the coil is there. So it's just one screw in there you can take off, and you can replace that. It's pretty simple to do. So always check that with your voltage and make sure that it is getting power to the reversing valve while you're working on it. Remember that most of all of Intertech and most other people energize the O terminal in cooling, so that's when it should be making its switch. So always take a look at that, check your wiring, check the continuity of the coil, make sure there's resistance in it, and you'll make this an easier project for you to diagnose. A stuck valve could be a result of a few things. Could we have a pilot or a main valve problem? In either case, while it is possible to unstick the valve, the fix almost always is temporary. If it sticks a second time, replace the valve. And we're going to discuss some more ways of changing it. Last failure mode is if the valve stuck somewhere between the positions. Well, it's usually difficult to diagnose. Valve stuck midway results in a significant amount of leakage between the low and the high side pressures, producing symptoms of a faulty compressor, high suction and low head pressures. So pay attention to the temperature and going through the valve and noticing some differences. We'll talk about that here in a second. Easiest test method to diagnose a stuck or a midway valve is to measure the temperature pressure drops across the valve. A pressure drop is always accompanied by a temperature drop. A valve stuck midway will cause a pressure drop or a mixture of warm and cool gases, and the differential would be measured across refrigeration paths, such as A to A or B to B. You'll need a very good thermocouple type thermometer to complete this test. Under normal conditions, a valve that is fully shifting should exhibit minimal temperature differences between the common paths. A temperature variation of over 4 to 6 degrees indicates restriction of flow or incomplete shifting. Um, Often the reversing valve stuck midway can be broke loose. There are several ways to do this. Most manufacturers, including Intertech, energize reversing valves in cooling mode, like I had said. By applying and reapplying power to the O terminal while it's even running, the valve may move to the proper position. By remeasuring temperature differentials, this can be determined. And as a last resort, take a screwdriver and lightly tap the valve tube near the ends. Care must be taken not to dent the valve body, because then we know we're going to be stuck for sure, right? In either case, a free valve will likely stick again. Here's another technical tip for testing a valve. A very small 1/4 inch super strong earthen magnet can be placed on the valve body. The magnet will be drawn to the steel slider through the valve body and will move with the slider, confirming the movement. Move it left to right. It varies by size and manufacturer, but will be a good indicator of the slider is moving internally. So this troubleshooting reversing valve sheet is also available from us. Let us know if you would like it, and we can get you a copy. Now, a lot of people have heard of AC Renew and some other chemicals that help free up refrigeration components, make things work smooth. I have some people that have tried this and have successfully loosened up a reversing valve, and but it may not work at all times. But it's something that if you're willing to try, it's available. The wholesalers out there. We do not carry it, but it's available at your local wholesaler. Pretty simple to inject into a system by hooking up refrigeration gauge hoses and pushing one from the discharge and running it into the suction line. Again, it's something you could try if you like. Obviously, we all know what the reversing valve looks like, nice and clean and shiny. We're going to talk about the combo unit here, and I want you guys to realize that in the combo unit, there's actually 3 valves, and they call them different. The first valve coming out of the compressor here is considered the direction valve. The next valve in the series of the refrigerant pathway is called the reversing valve. And then they also have what's called the 3-way valve up here. And the 3-way valve is most commonly susceptible to problems if you're having radiant flow or hot water making to a buffer tank or storage system. It's typically the one that gives you the most grief. Again, recommend checking while you're in these modes to double check the voltage to them, double check the resistance in the operating coils, make sure they're all working. Remember, the reversing valve pretty much only shifts during the heating and the cooling mode, and then the directional valve and the 3-way valve are energized during the hot water mode. So keep that in mind if you're servicing or diagnosing them. Now, if you're in water heating mode, you can see how the path of the refrigerant has changed, right? So the directional valve has changed, the 3-way valve has changed to change the direction of the flow. These diagrams are in most all of our manuals. If you don't see one in an old manual, our newer manuals will have these, and they're very similar to older ones, so you can follow the path. Makes it a lot easier for a diagnosis. And it also will talk to you whereabouts, take some temperature measurements to work on your superheat subcooling factors. Good testing thermometers, clamp-ons are the only way to put these in on the in and outs of the reversing valve and start looking for your temperature differential. Again, like it said, 5-6 degrees usually means there's something wrong. There shouldn't be much change going through them. And again, we mentioned you can energize the O even with a jumper wire. If you're in a heating mode, jumper to O, you can hear these things shift pretty loud. Is another component, a way to make sure your valve is operating properly. Boy, a bunch of neat tools you should have with when you're changing one of these guys. The vacuum pump, nitrogen obviously is very key important to keep the cleaned. New filter dryer, the torch assembly, tubing cutters. Remember, these should not be cut with anything else but a tubing cutter. I'll show you some pictures there in a while. And a vacuum gauge is always good to have when you're doing a repair. You ever think about safety? How about do you carry a fire extinguisher Wet rags and water, greatest thing to do for cooling each individual tube as you're resoldering them together. Be prepared, be safe. Don't want to see fire started in anybody's home, or don't want you to see in front of the judge or the law enforcement people saying, hey, you got troubles here, buddy. So be safe. Here's a picture of a reversing valve and a cannibalized heat pump, obviously, showing you tubing cutters and where to make some cuts. Intertech recommends cutting these things out and not unsweating them. Unsweating them makes oil burning, creates more contaminants that are going to plug up somewhere else in the system. So I'll show you here in a minute a spider assembly and what they prefer you to do. One thing I always recommend, if you're going to change one of these the way we do, take some photos. Some of these pictures have shown you the direction of which the copper tubing valves are associated according to the valve. Take a few pictures so you can remember the orientation. And I'll show you here something else in a minute. Again, I've had people come in with the Sawzall and, oh, where do you think the chips come from cutting the tubing? Bad move. I only want to see tubing cutters. Don't want to see a hacksaw. Don't want to see a Sawzall. All right. So after you cut this guy out, as I showed you here, as you've seen the one that I have here in my hand, all right, you got all kinds of different pipes facing different directions. This is why I recommend taking a picture so that you can look at the orientation of which way the tubes are going. And it's really important to take a look at, which way they're coming out of the valve here. And tubing cutters, make sure you got some refrigeration couplings. And to make it easier, so you only have to solder far away from the valve and not damage the valve when you're replacing it. Now, as I'm showing you here, take a picture of the valve laying down so you can orientate which way those valves are actually facing when you resolder the stubs back into the new reversing valve or three-way valve. All right. Again, it's all about not overheating that valve and creating more problems. Welding, soldering, however you desire to call it. We want to use a carburizing flame, which is a little bit more acetylene than oxygen, prevents oxygen getting into the system. Remember, Intertech, Emerson, Copeland, or wherever we get the valve manufacturers from, may not warranty the valve if they see it being unsweated. If that valve is called back for recall, don't get the chance of not getting your money back. So remember, this is important. Cut them out like a spider assembly and then put them back in and weld couplings in. Using your nitrogen, obviously, use your nitrogen. So in a short review, when changing a reversing valve, always check the refrigerant flow to determine if the valve is shifting properly before condemning the part. Use tubing cutters. Do not use saws when removing the reversing valve. Chips, metal shavings and stuff will create more problems and lock up other valves. Replace the reversing valve while using safe practices to ensure no fires or no line contaminations. Purge when you're done. Purge everything out with nitrogen so that nothing can be in there blocking or in the lines. You want to make sure the vacuum pump is going to come up here to clean all your fitting connections well, clean them up, resolder, wrapping the tube with wet rag, keep the valve cool. Evacuation is very important properly, using the vacuum gauge and recharge afterwards to factory specs. I think it's really important because most people change a valve, recharge it, and run away. But I expect you to recheck your superheat, your subcooling numbers. Make sure this thing is running the way it's supposed to be. All those numbers are available typically in your IOM manual, or they're online, or we can help you out in tech support. Most importantly, especially with this combo unit, run it in all modes. Check the proper refrigerant flow, check its proper operation. And with that, I'd like to thank you all for attending. Again, more of these have been recorded and are available on our Intertech University YouTube page. And if you have any questions, submit them to us at techservices@intertechgeo.com. Thank you, folks. Have a great day.